Hello, everyone. So there are so many of us, so many of you, and I'm really happy that I have chosen this sweatshirt for this meeting. So this is the comfort zone, and I'm struggling to enter it, but as you can see, it's still difficult. So, test metrics and their usage. We have heard the word metrics so often today. Let's wrap up this experience and this evening. First of all, let's check. Who has heard about Quantore? Great, there are some people who have heard about us. So, what is important to know is that Quantore is an international company, IT company, and we focus on producing complex solutions in healthcare and life science domain. Also, you should take a note that we have a development center here in Yerevan, in Georgia, where I traveled from, also in Kazakhstan, in Portugal, and we have business development centers in the Netherlands, in the UK, and the head office in the US. Also, we have a corporate university. So, on the one hand, we focus on professionals that have substantial experience in the IT industry, and we offer a range of courses. You can see these courses here. And we also suggest education for professionals that have minor experience in the IT industry. And currently, we are launching a data engineering school, and the registration ends soon. So scan the code, because the school is really good. And finally, some words about me. I have a long and diverse experience in the IT industry. I have worked as a manual and automation QA engineer. For 3 years, I have worked solely as a Scrum Master and built scaled Scrum process for parallel development of 4 related products. And now I'm a QA lead at Quantore. Also, before coming to the IT industry, I was studying and teaching in universities in Russia and Germany, first philosophy, then literary studies. And you might be surprised, but this really helps me in my everyday tasks. So, what we are going to discuss today? First of all, we would talk why test metrics matter. Secondly, we would look at some difficulties and what we may do to overcome them. And finally, we will check which test metrics can be helpful for you, or maybe not. So, first question, why do I need test metrics? A life of the QA engineer is already quite difficult. We have so many tasks on our shoulders. Why should we add another one? I will start from afar with this wonderful meme. I really like it. So there is a person who is saying, God has sent us trials to check how we are going to endure them. And the second person reacts, what do you mean by how? Badly, freaking badly. What the hell of the experiments are these? And to add more gravity, I'd like to present you the word of the year 2023, by the German Language Society. It's Krisenmodus, or crisis mode. And I really like this word because for me it really describes the year 2023. So, The long answer why we need test metrics would be that we are living in a constantly changing environment. And we have to make decisions quickly and adapt our plans quickly. We don't have time for elaborate planning like we used to have when we used waterfall model and so on. My suggestion how we can navigate through this crisis mode is that we should make hypotheses and then check if our assumptions were correct or not. And for this, we need data. We need data to make, first to check yesterday's weather, then to make predictions, and when we arrive at this moment in the future we predicted about, we need to check whether our assumptions were correct, and then adapt our decisions and make better informed decisions. So ideally, it should look like this. So we are here in the starting state. We make a hypothesis. We experiment. We take actions and we take measurements. Then, after some time, we arrive at the current state. We inspect and take measurements again, and then we adapt our decisions. And ideally, we would arrive at strategic goal. So, as an example, this is quite typical how Scrum team works. For instance, at the end of the sprint, we have understood that we have not completed all tasks in the sprint. So we make an assumption that this is because we have taken too many tasks in the sprint. So we make a management, we check the story points that we closed in the previous sprint, and at the next sprint planning, we take the amount of story points that we are likely to close. Then, at the next end of the sprint, we check our metrics, check our tasks, and sadly, we did not close the tasks, all the tasks in the sprint. So we make another assumption. We say that this is due to the fact that our integration testing took too long. So it took 5 days to complete all integration testing for the feature. Then we make an assumption that we need to talk with DevOps and they will help us to improve the pipeline, and that will increase the integration testing. So we conduct this experiment and we check if it will work. And this is the circle how we check our assumptions and adapt. And finally, we may arrive at our goal and complete all tasks in the sprint. But, of course, this is an ideal situation. And you may find some difficulties if in the real life. This is a really nice graph that shows you the relation between global temperature and number of pirates. And as you can see, the amount of pirates is reducing, and at the same time, global temperature is rising. So we may deduce from this graph that there is a connection between pirating and global warming. But our common sense tells us that things are a bit more complicated. And in the real life, there are some factors that can explain better why there are fewer pirates and why the temperature is rising. This is the first difficulty. What are the difficulties we may meet? Well, one of the problems is that we may approach the problem locally. And this picture is a nice example. When we see a big problem, like problems in delivery rate, and people take some aspects of the problem, like not enough QAs, few metrics, poor QAs, bad QAs, queues are too long, lack of transparency. And at the same time, although they are pointing to important metrics, still we don't grasp the full picture. So data is good, but we also need system thinking. Otherwise, we may end like the owner of this bike. At the close range, the bike is locked and everything looks fine. But if we take the whole picture into consideration, then we will see that this way of locking won't actually work and our bike might be stolen quite quickly. So we really need to observe the system as a whole. We need to identify the elements of the system and connections between them. And not to lose anything in the process, we need to visualize it. A good instrument for this are causal loop diagrams. They can be quite detailed and intricate, but I'm presenting you the simplest one. So, here is the workflow. We identify the problem, make a list of causes, then make a list of consequences, and then link them, these consequences, to causes. That is why it's called causal loop diagram. Another good benefit about causal loop diagram is not that they only help us to visualize the system, but also to visualize consequences of adding short-term fixes. Here in the diagram we can see that adding a short-term fix to a problem can end with unintended consequences that would add to the existing problem. And here I have a cautionary tale for you to share. So, once I worked in a team that had problems with delivery rate and delays to production. So the management decided that it would be much easier to add more developers to the project. That was nice, but these new developers produced a lot of code, and the current amount of QA engineers could not cope with this amount of new features. So they hired more QA engineers. Unfortunately, this did not speed up the delivery. And the next step of the management was to hire more middle-level managers, because obviously all these many employees, they needed proper governance, proper monitoring. But even this did not help to speed up the delivery. At this point, management was at a loss. So they decided the problem is obviously not with middle-level managers. They were picked by executives themselves, so they could be wrong. They could not be wrong in their selection. Obviously, the problem is with employees. And they decided to transfer the whole work on the project to another team. Because in another team, people are different, they code in a different way, they test in a different way, they are made of different stuff. Well, I don't know, unfortunately, how the situation unfolded in the next, as time passed, because I was not in this team. But I'm telling you this cautionary tale, because for me, it's a good example. First of all, how a series of short-term fixes can add more unintended consequences to the problem and make the problem more complicated. And also, for me, this is a situation, this is the case where we could really use causal loop diagram to make executives more aware of what is happening and to have really cool visualization of what they are really doing without offending them. There is another technique. Maybe some of you have heard about it or have used it. It's 5 whys technique. If you are not good with arrows and schemas, but are good with words, like myself, you can try this. So, how does it work? We state a problem and ask a series of why questions that help us to define the root cause. For example, the client comes to you and says, test engineers work slowly. We gather our team and start asking why. Why do they work slowly? Because there are too many items in test. And why are there too many items in test? Because there are a large amount of bugs found during feature testing. And why do we have so many bugs found in the feature testing? Because at the moment, developers don't have a complete picture of the requirements. And why is it so? Because our refinement process doesn't work as expected. So, as you can see, this technique helps to find out the root cause, and it can show you that, in fact, the problem lies not within the test process, but somewhere much earlier, for example, somewhere at product discovery. Well, I have told you why metrics matter. I have told you what problems we might have. Let's finally have a look at what metrics you can pick. But as usual with me, we will start from afar. I will start with this really nice quote from the Argentinian writer Jorge Luis Borges. In one of his short stories, he speaks of a certain Chinese encyclopedia. In this encyclopedia, animals are divided into those that belong to the emperor, embalmed ones, those that are trained, suckling pigs, mermaids, fabulous ones, stray dogs, those that are included in this classification, those that tremble as if they were mad, innumerable ones, those drawn with a very fine camel's hairbrush, others, those that have just broken a flower vase, those that resemble flies from a distance. If you are confused, it's okay. If you are lost somewhere in the first lines of this quote, it's also okay. You may be asking yourself, why have I chosen this quote for the presentation about test metrics? In fact, For me, this quote illustrates quite well the frustration I feel when I first approach the topic of test metrics and read about typology of test metrics. If you go to the internet and start Googling it, you will find articles like 64 essential metrics needed for your project. And then you start to read these sheets of text and you got confused, you got lost, same way as you just got lost with Borges. Why is this happening? Well, strictly speaking, it comes from the definition of metrics. Metrics are indicators that describe various attributes of a product or a process. So, as you can imagine, there can be multiple metrics of various products and various processes, and we can invent many of them and can write really long articles about them. For example, you may have heard about test metrics divided into product metrics and process metrics. And if we take product metrics, you can check your test coverage, the amount of bugs that you found at different stages of development. If you are looking at process metrics, there can be amount of tickets awaiting testing or your cycle time. So the period of time between the moment we started development and the moment we think the feature is ready for delivery. And there are many, many more. How we are going to navigate between all these metrics? In fact, we should start with ourselves. And we should start with the question, what do I want to learn? Then we should check ourselves and ask, is this the right question? And only after this, we can ask ourselves, what metrics can help me to address this particular question? And while choosing, please don't pick isolated parameters. I have talked a lot to you about the danger of picking isolated metrics, like number of pirates, and develop your metric set that will show you the whole system, the big picture. And practical question, where to find your metrics? Well, the answer is simple. We live in the 21st century, the information is everywhere, so check your test management tool, check your project management tool, also look through your bug reports, your Excel sheets, or maybe emails from your customers, anything. What is important is that you need to collect your metrics systematically and regularly to get your full picture. And please don't get afraid of all these pieces of advice. In fact, you can start with something simple. For example, you can go to your project management tool, like Jira, click on the Reports tab, and choose Cumulative Flow Diagram. This is my favorite type of diagram. So here, we have a diagram about tickets, the amount of tickets, and the time duration within 1 month, October. And these different colors show the amount of tickets in progress, in code review, ready for QA, QA, and peer review. So what do you see from this diagram? A lot of ready for QA. Yeah, this thick red stripe doesn't go a bit thinner. That's true. Also, we can see this, how can I put it? This steep line where the amount of tickets reduces, not for ready for QA state, unfortunately, and this is in fact the date where the sprint ends. So as you can see, here the amount of tickets in progress reduced rapidly, and there are much more tickets in code review and loads of tickets in ready for QA state. What can we conclude from this diagram? What assumptions can we make? Yes. Yeah, you're absolutely right. I'm showing you just one diagram, so there might be multiple conclusions possible. But for example, if it is our team, we already know the amount of QA engineers in our team, and we know how tasks are distributed, manual and automation tasks. And for example, one of the conclusions may be that we have quite a lot of developers and only one poor QA engineer who is trying, who is trying to cope with this large amount of tasks. Another example of what we can do, how we can start with a simple way. For example, your client comes to you and says that your amount of bugs in production is quite high. And you can go to your team and discuss with them using 5 whys technique what you can do and what may be the root cause. Oh, that's a really cool observation. Thank you for this observation. Yeah, if you are searching for answers, it's good if you have working relationship with your team and there is a good level of trust. And as a Scrum Master, I would say that there is a lot to work with. But still, since this is an introduction of tools, I would like to share with middle or junior QA engineers that if you need some troubleshooting, or if you need to investigate a middle or small scale problem, you can really use 5 whys technique, taking an assumption that you trust your team and there are some working relationships and working communication flow in your team. And a final example, pie charts as usual. So here we have the parameter, known issues in production. What is special about these pie charts is that they, on the one hand, show you how this amount changed through time. So this is release 1, 2, 3, 4. And colors tell you where, in which release, the bugs were introduced. So what is good about these pie charts? They help you not just to evaluate your current situation, but also to check how the process has developed through time. So if your manager or your client comes to you and asks, how many known issues do we have in production? You can produce not only the number, and the current number is 4, but also you can show him or her positive dynamics. Earlier, these were 16, and now we are definitely improving. So to summarize, we have talked about why metrics matter. We have talked what difficulties we may encounter with them. And we had a look at what metrics can be helpful for you. So, to conclude, I would like to stress 3 points. First of all, you really need metrics to make better informed decisions. Next, there is no golden or universal set of metrics. You need to develop this set yourself. Don't Google it. And finally, don't be afraid of test metrics. I have shown you these examples to illustrate that metrics are not frightening, and you can start with something simple and still start making better informed decisions.